All right, guys, this is our last example for 7.1. In this particular example, we're looking at people that have a certain blood type, and they are asking for the number of people that have a specific blood type, which is R positive, and they give us a percent of people that have it. So that would be our probability of success in this case. So if you're kind of taking notes about just given information, this is what I would write down. Keep in mind, you always want to write your percent as a decimal. So if my probability of success is 85%, then my probability that I fail is the complement of that, which would be 0.15 or 15%. Okay, so once we've established that, now we can look at what the question is asking us, what probability they want us to find. And they want us to figure out the probability that fewer than 39 people in a random sample of 40 have R positive blood. So fewer than 39, I want you guys to think about what that looks like for a second. So if we let X just represent this random event, and you can always use X if you guys want to, what does it mean to be less than 39? Well, we would be here all day if we approach this from a very straightforward and direct perspective. We would have to calculate that nobody has it, or that one person has it, or that two people have it, or all the way up to 38. Now, you could absolutely knock yourself out and do every single one of those, all 39 cases, but I don't want to do that. That's going to take way too long, and especially on an ACE exam when you have a limited number of time. So to think about a faster way to do this, if I'm not less than 39, then I could be greater than or equal to 39, right? And let's look at that complement. So to calculate the probability that X is less than 39, well, that would be the complement. So to find a complement, it's always 1 minus the probability, right? And that's very similar to how we came up with these right here. And the complement for being less than 39 would be greater than or equal to 39. So what does that look like? Well, greater than or equal to 39, that would be, and I want to put this in brackets because I'm subtracting it, and there's going to be more than one event in here. Greater than or equal to 39 would be, well, it could equal 39, or it could equal 40. And we stop at 40 because our sample is only of 40 people. Okay, and this is a heck of a lot less work than it is to calculate the probability of 0, 1, 2, 3, 4, 5, all the way up to 38. So let's definitely take the shorter route here. So once you've established this notation and you understand what it is that you need to find, then you can kind of come off to the side and you can do each one of these individual probabilities. So let's figure out the probability that, 39 people have it. And to do this, you can just set it up like we did the last few. The total number is going to go on top, so 40. And the number of times you need to succeed would be 39, times the probability that we succeed in this case is 0.85, or 0.85. And we're going to raise that to the 39th power, times the probability that we fail, 15%. And I need to fail once, okay? And if you type that into your calculator, you should get this decimal, 0.0106044479. And we also have to calculate the probability that 40 people have it. So that's everybody has it. And we would do 40, choose 40, 0.85 to the 40th power times 0.15 to the 0 power. So if you type that into your calculator, you are going to get 0.001502 301. And what we do with these two is we add them up and we subtract their sum from 1. Okay? So if you plug these two pieces of information back in right here, and you type that into your calculator, your total answer is going to come out to be 0.988. So now we can round to 3 significant figures because we're done.